All right, welcome to 7E, and it's going to be the practice. So your practice problems, which are, I'm going to give you the zeros, which another name for zeros are solutions, and you're going to have to come up with a potential polynomial for them that would have those solutions or zeros. So first thing, set each zero equal to x. And since -1 is a multiple of 2, we got to write it twice. And x equals 4/5. Next step is to make each little equation here equal to 0. So right now it's x equals -1, so we add 1 to make the equation equal 0. X plus 1 is one of our factors. And of course this next one is going to be exactly the same because it was the same 0. So x plus 1 is your factor. And now the fraction. Typically, people look at that as a division, 4 divided by 5. So the opposite of divide by 5 is multiply by 5. And then you can subtract 4. And it equals 0. So 5x minus 4 is your factor. Now you set the factors. You write the factors out in a function, with a function. This is the factored form of the polynomial. And lastly, we need to multiply out these factors. So you multiply 2 factors at a time. I'll just multiply the first 2 together. You can do this with a Punnett Square if you'd like, or by double distribution. I'm going to do it with a Punnett Square. So x times x is x squared. Remember, you're adding exponents with like multiplying like bases. And 1. Your like terms are right in the middle here. So this will end up being f of x. You can write anything you want. You don't have to have fx. It could just be y. X squared. X plus x is 2x. 1x plus another x. 1x plus one more x is 2x plus 1. And we still have that 5x minus 4 that comes down. Now we have a trinomial times a binomial. So let's multiply that out. Doesn't matter, you can have 3 rows or 3 columns by 2. So we have x squared plus 2x plus 1 and 5x minus 4. Multiply these out. 5x times x squared is 5 like bases, add exponents, so 1 plus 2 is 3. 2x times 5x is 10x squared. 1 times 5x is 5x. X squared times -4 is -4x squared. -4 times 2x is -8x. 1 times -4 is -4. Looking at our like terms, always, let me do that in a different colors because it's a different term or different like term. They're usually diagonals of each other. So when we gather these all together, you're going to get, always write in standard form. You want to write biggest exponent to the smallest. So we have 10x squareds, and we're subtracting 4 of them, giving you 6x squareds. 5x minus 8 is a -3x, or 5x minus 8x, and then minus 4. And that is your polynomial for the given zeros. That polynomial would have solutions at -1. It'd have a multiple of 2, a double, and 4/5. Number 2, so set each factor or each zero equal to x. So it's a positive 2i, x equals a -2i, and x equals 0. So we have subtract 2i, subtract 2i. I know it's imaginary, and I know it's kind of weird, but we can subtract them. So we have the factor x minus 2i. X plus 2i. And the last one, is just x. Write these out in factored form of the polynomial. Typically you'd write the x first, but it really doesn't matter. Looking at multiplying this out, since two of our factors have imaginaries, I will actually multiply those together. The main reason why I'm doing that is you have imaginary, when you multiply it times an imaginary, is going to give you a real number. I times I is I squared is -1. So we have x minus 2i and x plus 2i. So, and these are conjugates. One's x minus 2i, one's x plus 2i. Conjugates, when multiplied together, will always simplify very, very nicely. X times x is x squared, negative 2xi, positive 2xi, and negative 4i squared. Now, when we're simplifying these like terms, they both have xi's. One's a positive, one's a negative. So hopefully you're saying, well, those are going to get, they're going to be opposite operations. They simplify out. We have I squared is -1. -4 times -1 is +4. So this ultimately, and it cleans up really nice. X squared plus 4. Then we have to multiply by x. I don't think we need to do Punnett Square here. You could. You have f of x equals x to the third plus 4x. There's your Punnett, or there's your polynomial. That would give two imaginary solutions. One's at positive 2i, one's at negative 2i, and the other one's at 0. All right, number 3, we have x equals 2 square root of 3, x equals a negative 2 square root of 3, x equals 1/2, and x equals -1. Oh boy. All right, let's do it. So we're subtracting this radical. X minus 2 square root of 3 equals 0. We'll multiply by 2. Subtract 1. And you get 2x minus 1. Add 1. You get x plus 1, 2x minus 1, x plus 2 square root of 3, x minus 2 square root of 3. Let's write these together as in the factored form of the polynomial. It looks wild, but I promise this is not going to be hold on a second. Oh, we got to keep going. We're going to keep going. Sorry. Had a moment of panic here. All right. Anyways, back onto this. When you are multiplying factors, you need to multiply 2 at a time. When you have 4, you can actually split it up into the first 2 and the last 2. So concentrate first on multiplying the first 2 out. So x times x. I guess we can do this in Punnett Square. That might be easier. We'll see. I've never multiplied radicals with the Punnett Square before, so it's kind of fun. All right, so x times x is x squared, negative 2x square root of 3, positive 2x square root of 3. See, they're still conjugates. So conjugates, one's a positive, one's a negative with the binomials. And they're going to end up, when they multiply out, to be something super easy. So negative 2 times 2 is negative 4. Square root of 3 times the square root of 3 is 3. That's like the square root of 3 squared, which is 3. So that's actually going to be negative 12. Middle two terms here are going to simplify, and we're going to end up with x squared minus 12. Now in the second binomial times binomial, we can do another Punnett square. 2x minus 1 does not matter which binomial goes where. 2x times x is 2x squared, negative 1x, or just negative x, 2x minus 1. Got your like terms. So we have biggest exponent first, 2x squared. That's negative 1x, so that's a positive x, or positive 1x minus 1. Still got more to do here. We have a binomial times a trinomial. Probably going to go to the Punnett square for this. And I'm going to write it over as a side, just to have some more room. So I have 3 rows, or you could have 3 columns, does not matter. So you have x squared minus 12, 2x squared, positive x, minus 1. 2x squared times x squared, so like bases, you're adding exponents. X squared times x, like bases, you're adding exponents. We have our like terms. Nope. Make sure I have these right. Yes. Where are our like terms? I feel like we have like terms here. We do. There's our 2 like terms, and that looks like it's it. Tricked me, almost tricked me. So, the function, 2x to the 4th, plus x cubed. Negative 24 minus 1 more is negative 25. X squared minus 12x plus 12. Wow. If you got that, awesome job. Anywhere close to that, great job. But that will give you the zeros at 2 square root of 3 and positive and negative, 1/2 and negative 1. Wow. Pretty awesome. Now, number 4. We have some craziness going on here. Looks like 2x intercepts. One's at x equals negative 0.5, and one's at 0. Now, if you notice, both of them, that is a little minimum point there, or maximum points, local maximums. Those are doubles, or multiples of 2. Both of them. And negative 0.5, we can rewrite that as x equals negative 1/2. So when we write these, we have x equals negative 1/2, another x equals negative 1/2, and x equals 0, and another x equals 0. So we're going to actually have 4. And you look, you have 4 different slopes there, so that's the minimum we could have for a degree. We're going to have 4 answers, so it should be to the 4th power. Multiplying these out, times 2, so we have 2x equals negative 1, add 1. You're going to do the exact same thing for the next one. And the last ones, those are already your factors. So our factors are 2x plus 1, 2x plus 1, x and x. Write these out as in factored form of the polynomial. Does not matter. Typically x's go first, but it really does not matter what the order you write these in by the multiplication property, or oh my goodness, totally forgot the property. Commutative property of multiplication. My goodness. So taking the first 2, remember we're multiplying 2 factors at a time, so x times x, that one's easy. Like bases, add exponents to have x squared, and we get to multiply 2x plus 1 times 2x plus 1. We'll do that over on the side of the Punnett square. One of these days I'll be able to draw a nice square. So 2x times 2x is 4x squared. 2x times 1, 2x times 1, 1 times 1. Like terms, 2x plus 2x is 4x. So we have 4x squared, plus you have 2 x's and you're adding 2 more x's, so you total have 4 x's. Then we need to multiply this monomial times the trinomial. You can do that in Punnett Square, otherwise we should be able to do x squared times 4x squared is 4x to the fourth. X squared times 4x, remember it's like bases, both have x's. You add with multiplication, you add exponents. And x squared times 1 is x squared. And there's your polynomial that would give you, it would look similar to the graph that's given. It will have the x, or the x-intercepts, a double at -1/2 and a double at 0. It may not look exactly the same, but it will have that. All right, hopefully this